All right, so this is a drop that I had on my shelf. It's some 1" by 5" flat bar. Had some rust accumulated on it, so I just cleaned it up, deburred it good. And what I'm using this for is just simply a mounting plate for this Cat 50 tool fixture right here. This is a TMX brand 50 taper or Cat 50 that I bought from KBC Tools. And I just want to get it mounted on this plate so that we can bolt it down to either the mill table or a workbench or wherever it ends up being. Just needed a good way to hold it. So pretty simple. Just got a 4-hole pattern. We'll drill and tap the plate. And then what I'd like to do also, the plate was just big enough that I can take and we'll probably just mill us a couple slots on the end so that we can use either a 1/2" stud or, you know, whatever. You can use a flange nut or bolt it on, but that way we can slide it in instead of having to drop it down in there. And then we could be able to mount this to our mill table or another workbench. I don't know where this is going to live, but I just need a way to hold it so that I can secure my tools. Like this guy right here, this is a 50 taper, Cat 50. I wanted to get this, I want to get some of these tools mounted up to be able to use on the flex pretty soon. And then this is what you use for the guys that aren't aware. You can use it to hold your tools like that, tighten these face mills up, or put an end mill in, or if you need to put the retention knobs on there, which I'm having to do, you know, you can do that. You can drop it down in here vertically like that so that you can, you know, work on your inserts there, get those installed or swapped around. So just need a good way to secure the tools, and that's what this is for. I'm sure a lot of you guys watching are already well aware of this kind of stuff. So just a real simple little shop project. Got some 5/16 bolts there that we'll use to mount it to the steel plate. All right, another quick little shop project here. We're continuing to fill out our tooling for the machines, and the KBC mill in specific is what this little project here. So this is a Jacobs drill chuck that I picked up. I believe I got this at the Florida Flywheelers last year. And my favorite size for a milling machine, it's the Jacobs 14N Super Chuck. But somebody had this for sale and it looked like it was still in good shape. Now whether it runs true or not, I don't know because I haven't mounted it yet. But overall it looks like a typical drill chuck that you'd see at somebody's workstation or on the machine. But Super Chucks, those are my favorite because they got that ball bearing in there. So whenever you go to tighten this down, you know, you can get a good amount of torque on that without it being too hard on your hand and your fingers there to tighten it up. So just a good overall chuck. Unfortunately, Jacobs no longer makes these in the USA. They moved their operations overseas. So if you get an opportunity to pick these up used, you know, and you can tell because the older ones have Jacobs USA on the chucks, and the new ones that you'll get only say Jacobs on there. But anyway, I got the arbor. So this is a 3JT arbor, and I'm sure these are made overseas there too, but these are inexpensive to get. But the purpose of this was what I was going to show you as a little tip to whenever you get these arbors like this, you honestly don't need this super long shank on here. A lot of times this hinders going up into a tool holder or even a collet chuck. So all you need is one section of this. So the best thing to do is just cut this extra off right there. That's exactly what I'm going to do. And I will give a shout out to my buddy Tom Lipton, Ox Tools. He's got this tip in his book there as well, and I enjoyed you know, seeing and reading that and realizing that I'm not the only one that doesn't like these super long shanks on a drill chuck. There's really no point in it. There's very few times that you're probably going to need to be able to have this long shank on a drill chuck, you know, to be able to extend it down or whatever. So for all your everyday normal use, for 99% of what you're going to do, all you need is this section right there. So we're going to go ahead and cut this off, get this installed in there, which is simply all you do. You can now some guys like to warm these slightly and then drop it in there, but I think we're gonna set it in there. We'll use a soft blow, give it a couple taps, and it should be good to go. We'll use our Famco #1 arbor press to get our, we'll just put a little pressure on it whenever we stick this in there to help press that in. This will be the first little project I use it for. So this guy right here, I didn't take any video of it, but a couple weekends ago I actually pulled this out of the garage and just did sort of like a mechanical restoration on it and cleaned it up. Took everything apart. You know, all the grease and the oil was just dried up on this thing and it was really hard to move. So really just cleaned everything up. Had to replace these bolts here because they were bad. But this used to be my dad's. And I found this in the back of the shop buried under a bunch of junk when I was either 17 or 18 years old. So right after I started working for Dad. And, you know, he wasn't using it. It was buried. And I had set up like a little small work area in our shed. I still lived with my parents at that time, where I worked on my dirt bikes and worked on anything, my lawnmowers, all kind of stuff. And so I had asked my dad, could I have this or at least take it home to use it? And he said, yeah, that's fine, you can have it, because he wasn't using it. He always used his grinder #3. So I've had it in my possession ever since that time. It's just been with me. So even though my dad gave it to me, it was still his, and it's nice to clean it up and maybe put it to work here. So I cleaned it up, brought it to the new shop, and it'll be here in case we need it. I think I'll be able to use it when we go to press the bearings together on the American Pacemaker compound lead screw. So anyway, we're just going to take our Jacob's chuck, and I got just enough room, so I want to make sure that we get rid of any of the dust on the taper end there. And I've already wiped the inside out. It feels good, so hopefully it'll be good. We're going to go ahead and just drop it in there just like that. Just get a little pressure with our arbor press. Line it up there. All right, and that should be it. Now we'll be able to put that in our collet, and hopefully it'll run nice and true. So let's find out. All right, we got our 3/4 collet. Well, let's see if it spins up true. Just hand tighten it for now. All right, awesome. I can see a couple thousandths run out in it, but overall I think it's going to be a good chuck for drilling holes. So that worked out pretty good. You never know. Whenever you buy these things used, it's really hard to determine whether they're in actually good shape or not. You know, typically the jaws have spun on you know, drill shanks and other tools over its life, so it kind of run a risk. So if you can get them for a bargain price, which is how I got this, you know, it works out pretty good. So our 4-hole pattern we're going to machine is metric. It's 115 millimeters in our X position, and it'll be 45 millimeters in our Y position there. So we'll center up in the center of the block and then just drill our holes. I'll probably use my flex arm to tap it, and then we'll mill the 2 slots. I went ahead and spotted our 4-hole pattern there just so that I can verify it, that we're on our correct center to center distance. I can see them all lined up, so we'll just go ahead and drill it tap size. High gear would work better. We'll go ahead and get the holes chamfered, and I'll just kind of eyeball this the depth that I want. Something like that right there. Should work. All right, this is going to be a good opportunity to try out my new helical end mill here. So this is 5/8 solid carbide fine pitch roughing end mill from Helical, and I actually got this to do the machining of the rails over on the Flex, but I think this is a good size cutter to use for what we're wanting to do, put our 2 slots there. And I'm going 5/8 so that I have the option to use 5/8 studs on this if I want to later. So I think I'm going to go ahead and give this guy a shot there. And I don't know if this or the mill will be able to handle a 1-inch depth of cut there on the sides. We'll give it a try and see how it reacts. It may be too chattery, too loud, not working good. If not, we'll just go half and half there. And we don't need very much there, just a little bit on each side, just for a stud and a nut to hold it down. So we'll give our new helical end mill a try. We're going to give our full depth a try. I do have my Noga Cool set up on this, so a pretty good amount of air pressure to help blow the chips and the coolant. Try to keep everything nice and cool. Well, our end mill definitely did the job and it worked good. Still getting that chatter in it, but that's just the nature of the beast. To kind of reduce that, I did exactly what I had mentioned before. I would just take it, just about a 1/2 inch at a time. And then what I did is I offset Y 5/1000ths on each direction just to kind of clean up the side so you don't see that step in the middle. All right, so we'll just move down. We've moved down to that side and we'll repeat and do the same thing. I slowed the RPM down a little bit, and we didn't get any chatter on this side, so I may have been running a little too fast. Let's see if we get that same performance here. clean up those sides. A little 5 thou pass each side. Just kind of help remove that little step at the bottom of the cutter. Go back the other way. All right, that RPM worked out beautifully for this cutter on the manual mill. So I'm running 520 RPM according to the dial up here on the top. That worked out pretty good. We'll get everything vacuumed up, cleaned up, and we'll go to the flex arm to tap our 4 holes, and then it's got to be ready to go. This is that deburr tool that I got from KBC. It works pretty good for deburring the edge. We'll use it to deburr these slot edges right there. All right, we've got you over here on the flex, and unfortunately I'm bringing you back at a later time because what was supposed to be a very simple and easy tapping operation has turned into an aggravation because I started tapping this hole here and the tap broke off all the way in the bottom. It was a brand new tap, brand new Cleveland tap. And when it bottomed out, the clutch for the tap holder here did not clutch out like it was supposed to, and it broke the tap off in there. Now I tried to get it out of there. I've got a couple carbide drills here and tried to get it out, and all it did was just tear everything up. So I decided to just, instead of worrying about that hole, I moved it in 12 millimeters, re-drilled it. I'm gonna re-drill the base of the Cat 50 tool fixture to match that, and it shouldn't be no big deal. Now, if this was a customer part that I was making for somebody and I had that problem, I would be remaking this. I wouldn't do this and give it to somebody because there was a tap broke off in there. But since it's my part and it's just a fixture to hold that tool clamp down, not a big deal. I did talk to the fellas up at Flex about these tap holders here because this is the second time that this has given me a problem. I've adjusted the clutch on it way out from what it should be adjusted, and it's still breaking a tap off. So what they're doing is they're going to send me, actually it's this guy right here, they're going to be sending me a new set of these tap holders here because they said that the manufacturer that they've had making these, they've been having some problems with these guys. So they're going to send me another set of the #1 size holders that maybe they're doing better now, the new batch. You know, I've had these since early last year, I believe. We're going to go ahead. So what I decided to do is go ahead and just drill them all the way through. So instead of doing a bottoming hole, we're just going to have a through hole, and I've got a gun tap mounted into the tap holder now. So should be ready to go now. I think I'm going to, yeah, I think we'll just leave it that speed right there. Should be pretty good. And then I'm using this tap heavy tapping fluid from Master Fluids. It's very thick. It's kind of like, has a consistency of like syrup. All right, let's give it a shot. I'm a little gun shy on this now. All right. All right. All right, well, the through tap through tapping is always going to be less frustrating than having to deal with a bottoming tap. So that worked out pretty good right there. So let's go ahead and finish the other 4 holes out. We're centered up on that hole. We're going to move it over 12 millimeters. Go ahead and spot it in first. So move it over our 12. There we go. And we got a 8.5 millimeter drill bit here that we'll use. All right, put a little chamfer on that. It's got to be ready to bolt on. All right, we'll go ahead and get this thing bolted together. So this is kind of what, my idea was, is having a plate that's kind of a universal mount to be able to mount it on a mill table, whether it be on this table, the table for the flex. It'll just have larger studs over there. That's why I went ahead and milled these to 5/8. Or ultimately what I'd like is for these guys, this is the 40 taper holder here, to be mounted somewhere in a more permanent spot on a workbench somewhere that's so it's not tying up mill table space. But this is going to get us by for now, just so that I can hold this, or have a way to hold the tools, to be able to load them up in the Cat 50 holders. I think they're going to have to be off just a little bit. Like I said, the plate was just what it was. Let's see. Yeah, that's good right there. All right, simple enough. There are 4 socket head bolts here. All right, the one on the back that I re-drilled, that's what's going in now. Okay, that's lining up. And the last one. This may interfere with the tools. We'll stick one in there and see. May end up having to be a bolt instead of a stud and a flange nut there. But that's getting us somewhere, making it more usable, that's for sure. Let's stick this one in here and see. All right, well, it's not interfering with it, so it looks like it's going to work just fine. That way you can, all the holders you got to have the retention knobs screwed into it, so you can come over here and use it like that. Or come over here and use it on this side just the same. All right. So this is the other possibility too. We're over here on the Flex CNC, and I'm not saying that this is going to live on the machine, but I can certainly mount it on here, especially, I don't know, maybe on the back corner. We'll have a spot there that we can use it or mount this up to. But show you what I'm talking about here. I'm going to have a different stud set to use over here on the Flex for fixturing these. We'll probably go with a 5/8 set of hold down for this machine. So there we go. That was the whole purpose of having the plate there. We can mount it wherever we want. If we go to a workbench, we can just simply have a couple tapped holes and have bolts holding it in place if we need to. So anyway, one little shop project done. I was trying to get this done because Aaron from Flex, he's going to be here in a couple of days to start doing some training over here. We're actually going to be getting these guys machined in, but I wanted to get this done beforehand so that we'd have it so that we can start loading up some of our 50 taper tools in the Flex.